struggling with additional mathematics and not sure how to improve? Hi, I'm Terry. For over the past 25 years, I've helped many students improve from failing grades to distinction in SPM and maths. So that's why I created Express Notes to help you focus on what really matters most. Today, we're going to go through chapter 8.3, Vectors in Cartesian Coordinates. Let's get going. This is the easy part of vector, I would say. You all know that one I is one movement to the right-hand side, one J is one vertical up. So we can write in, for example, if I go 3 unit or 2 unit right, 3 unit up, you can write this as 2i plus 3j, or you can write in column vector 2, 3. Column vector is like your translation vector in your form 2 translation, right? We can write like this, okay? So I think all this I don't have to explain, but a quick one about position vector. So I'm sure you see this before. PQ means what? If you want to go from P to Q, I can go P to O, O to Q. PO is actually negative OP, right? So normally I'll put OQ in front and minus OP. But if you don't want to do this, right, please do one by one, not P to O, O to P, O to Q. Because some people, they messed up, like AB, right, is always OB minus OA. It's always the second letter with respect to O minus the first vector with respect to O. If I give you RS, it will be OS minus OR. If you're unsure, then it's okay. You just do R to O, O to S, right? You always have to pass through O. Position vector is always respect to O relative to point O. Okay? So RO is just negative of OR. Okay, so let's talk about magnitude. Magnitude is very simple. If let's say you have a vector like 4i, 3j, the magnitude, we just use a simple Pythagoras. Vector R, the magnitude, let's say vector R is 4i plus 3j, right? Your magnitude of vector R is 4 square plus 3 square square root. Answer is 5. Then let's talk about unit vector. What is unit vector? Unit vector is basically a vector that moves in a certain direction, but the most important thing is the magnitude is always 1. So how do you make the magnitude 1? For example, just now, this vector R here, it has a magnitude of 5. So that means I can divide into 5 equal parts. So to find one part of this, we write this as R with a cap or hat, is basically vector R divided by 5. So when you divide by 5, you get 1 unit. Yeah, we call this a unit vector. Okay, one example, example 13. Here we are given vector point Q, point P. Now remember, if you're given coordinate of P, meaning this is OP, we can write this as 5 minus 7. And this is OQ, we can write this as negative 3, 8. So your vector QP, we can write OP minus OQ. If you don't want, you can write Q to O plus O to P. OP is 5 minus 7. OQ is minus 3, 8. Put together, you get 8, negative 15. Then we want to write unit vector. Find unit vector. Before you find unit vector of PQ, let's find out what is PQ. PQ is negative of O of QP. Yeah? So I just put negative in front, plus positive 15J. What is your magnitude? Your magnitude will be negative 8 square, 15 square square root. That will be 17. So your unit vector will be minus 8i plus 15j divided by 17. Now take note, the first part they asked to give in column vector form. Second part we write in I and j form. Okay, or if you want, you can separate them to negative 8 over 15i, 17i, 15 over 17. Okay, so this is very simple. We all know addition vectors can be added, can be subtracted. So for example, vector A, vector B, you can add together A, B, C, put like this. If you want to subtract, you can just subtract one by one. Yeah, sorry, a bit off here. And then if you want combined operation, we can do plus and minus. If you have a scalar means a number in front, we can multiply inside the K, you can times in one by one. I think I'll go straight to one example. This is fairly simple. Okay, so if I want to find vector C, right? And C
is half of A. They write in this form. Your A is 6I minus 8J. And then your B is I minus 5J. So when you expand, you should get 3I minus 4J, right? 3I minus 4J. And then this is 4I minus 20J. Yeah? So the end result will be 3 plus 4, which is 7. Minus 4 minus 20 minus 24J. Okay, then to find unit vector, like what we said earlier, unit vector, you first have to find the magnitude. 7 square minus 24 square root, this is 25. So your unit vector for C, we just put a cap here. Take this vector, divide by its magnitude 25. Here I just split into two. 7 over 25I, 24 over 25J. Here you're given a parallelogram. Everyone, you're given a parallelogram OABC, and M is the midpoint of BC. Given that OA is 4, 6, OC is -5, 1, find vector MA. So to go from M to A, right? Okay, so we can use the concept that we talked about earlier. MA will be M to B plus B to A. Now, MB is actually half of CB. Half of CB. And your CB is actually the same as your OA. Whereas BA, right? BA is actually opposite of OC. Okay, now I'll just write BA here. Just write very slowly. Your CB is the same as OA. So I'm going to put 4, 6 inside. And your BA is negative OC. Because OC is going up, right? OC is going up. CO is going down. CO is parallel to BA. They are going in the same direction. Actually, they're equal. Not only parallel, they're equal vectors. So we should add this up. This is 2, 3 minus -5, 1. Answer 7, 2. That is MA. Okay, to find unit vector of OM, right? We need to go from, now you can use the result, or you can go O to C, C to M, up to you. Now, when I say use the result, means I go O to A to M, because I already know the result from part A. My OA is still 4, 6. My AM is negative of MA. In this case, is -3 and 4. And remember, unit vector is a vector divided by its magnitude. The magnitude of OM is square root of -3 square plus 4 square, which gives us 5. Unit vector for M, I can just write M with a cap. Take this vector, -3, 4, divide by 5. Now, but normally we don't divide by 5. We times 1 over 5. Okay, so if you multiply inside, you should get this answer. So for here, in this case, we have to sub inside. Now, AB, guys, what is AB? I've explained to you guys before, right? AB, we can use OB minus OA, right? So it's a faster way of doing. So I'm going to write here, OB minus OA. BC will be OC minus OB. I put together, the result is 9I minus 4J. But instead of writing in IJ form, I think it's better to write in column vector form, like this. You can sub inside directly, because we know OA is basically, if you write in column vector, this is just HK, right? OB is basically -2, 5, right? OC is basically 4 minus 3, if you write in column vector. So here my OB is -2, 5. My OA is HK. Let's count what's your OC. My OC is 4 minus 3. OB is -2, 5. Put together, the result is 9 minus 4. Okay, so here I think we can just put them together again. -2 minus H, 5 minus K. This is 6 minus 8, right? The result, 9 minus 4. Okay, so let's bring this to the right-hand side. So when you bring over to the right, it's going to be addition. You're going to add them together. This is -2 minus H, 5 minus K. You add them up. This will be 15. The other one will be -4 minus 8 minus 12. Now notice you have a 3 in front. So I can actually divide them. So when I divide them, 15 divided by 3, I get 5. Minus 12 divided by 3 minus 4. So by comparing one by one, let's compare the I component. Minus 2 minus H is 5. H will be negative 7. Then you compare your J component. 5 minus K is negative 4. K is 9. So here you are given QR equals 2 times of PQ. So let's find QR first. QR is what? OR minus OQR. Like I say, if you can't do directly, you can do Q to O, O to R. Okay, Q to O is negative OQ. And then what is your PQ? Your PQ is OQ minus OP. My OR I already know. I don't know much my OR. In fact, I'm finding OR. Okay, I know my OQ. Okay, now some people may not sub in yet. Okay, I tell you what, I don't sub in first. I put 2 OQ minus 2 OP first. Okay, let's bring the OQ over to the right. You get 3 OQ minus 2 OP. Since I know my OQ, right? This is my OQ. So put it in. K minus 2. I know my OP. My P is 4, 3. Put them together. This is 3K minus 8 minus 6 minus 6, isn't it? Minus 6 minus 6. So you can write one extra step if you want. 3K minus 8 minus 12. Okay, so with that, this is my vector OR. You have to find vector OR first. And then it is given that vector OR has magnitude of 13. You're supposed to find possible values of K. Now remember magnitude, if I say vector R is xi plus yj, what's your magnitude? Your magnitude will be x squared plus y squared square root. So this will be 3k minus 8 square plus negative 12 square. The whole thing square root equals 13. So what I need to do is to square both sides. This is 3k minus 8 square. This one you can write 144. This is 169. If you minus it, it's 25, right? Square root of 25 is what? Plus minus 5. There is a negative value here and a positive value here. Our job is to find k. K is 3 over 3, right? 3 over 3 is 1. Okay, let me do a bit slower here. 3, 1. This is 13. 13 over 3. Yeah, two answers are K is 1 or 13 over 3. Okay, so I want to find I want to find H. I know that they are parallel. So if the first vector is parallel to the second vector, so we say A is lambda B. Now, it doesn't matter, like guys, some of you may say, oh, must I really write an IJ form? No need, because it is not related. The final answer is independent of whether you write an IJ form or column vector. So I like column vector because it's easier. Don't have to underline, don't write so many steps. Right, this is my A, lambda. What's your B? Your B will be 8 and a H plus 2. Okay, so we just compare. 3H equals to 8 lambda, first equation, minus 9 equals to lambda H plus 2. Whether you put the lambda in front or the back doesn't matter. Okay, maybe I put H plus 2 in front, the lambda at the back. So what we want to do is we want to solve for H, right? So let's take equation 1, divide equation number 2. So when you divide them, the lambda you can cancel out, right? You can see that? I can cancel my lambda and lambda. This is negative 1 over 3H. This is 8 over H plus 2. So what we have here is a quadratic equation. When I cross multiply, rearrange it. Okay, sorry, this is I think this one has to change to plus. This one's a plus. Okay, can we change this to plus? So this is a plus, otherwise you cannot factorize. So this is positive. Positive. So let's bring this over. This is H minus 24 equals 0. Double bracket, factorize them. H you should use 6 and 4. 6, 4 plus minus. So my H is either 4 or negative 6. We're finding expression for n in terms of m. So let's draw a diagram. OPR. O is here. Let's say P is here. Q is here. R is here. It is given that PQR, they are collinear. So you can use any combination. You can use PQ equals to lambda QR, PQ equals to lambda PR, any combination, up to you. Okay, maybe I just use PQ equals lambda QR. So my PQ will be OQ minus OP. My QR will be OR minus OQ. My OQ is N and 2. My OP is M minus 4. Lambda is an unknown. OR is 6, 5. OQ is N 2. Put them together. N minus M. 2 minus minus 4. 2 plus 4 is 6. This will be lambda 6 minus N and 3. So when you compare, right, N minus M is lambda 6 minus N. I can't solve this, so I'll leave it out. Yeah, I'm comparing the I component followed by the J component. 6 equals 3 lambda. Your lambda is 2. So let's take this and sub inside equation 1. My N minus M is now 2 of 6 minus N. Everyone, what are we finding? You're finding N, right? N in terms of M. So let's expand this. This will be 12 minus 2N. Bring over 3N is now M plus 12. When you divide by 3, up to you. You can write M plus 12 over 3 like this. Or you can write 1 over 3M plus 4. When the vector is parallel to x-axis, it can be expressed in terms of I only. For example, when the line is parallel to x-axis, it can only go right or left. So that vector is a multiple of I. Your lambda, the multiple, can be positive, can be negative. Even if it goes to the left, right, it is still parallel to x-axis. Okay, but the most important thing is that the J component is 0. It doesn't go up or down, it just go left or right. Now, when a vector is parallel to y-axis, on the other hand, your I component is 0. For example, vector B parallel to y-axis, right? Let's say this vector B, it can be lambda J. Yeah, we write B equals lambda J. Again, your lambda can be positive, can be negative. I can go up, I can go down, but it doesn't go left, don't go right, just up and down. Yeah, but again, most important thing, the I component must be 0. Okay, so let's look at one example, example 20. Now, in this example, vector P and Q, they are given. You're supposed to find vector R such that, you're supposed to find K such that this R is parallel to x-axis. If your R is parallel to x-axis, your R must be lambda I, no J. But first, we find out what is your R. We take 3 times P. What's your P? Negative I plus 4J. Actually, guys, if you don't want to write in IJ form, it's okay one. You can choose not to write in IJ form. It doesn't matter. You can write in column vector. So this one plus KQ, 5I minus 2J. So let's multiply inside. Minus 3I plus 12J plus 5KI minus 2KJ. So put together our I component. This is your I component. Put together your J component. And then, like I say, the most important thing, what happened when it's parallel to y-axis, x-axis? This is lambda I plus 0J. Your J component must be 0. Let's take 12 minus 2K. Let it be 0. 2K is 12. What's your K? Your K is 6. Okay, then how do you find magnitude of R? Okay, very simple. Now that we know your J component is 0, we know K is 6. So let's take this and sub inside here. Now, when you sub inside this part here, what is your K now? Your K is 6, right? So we take 5 times 6 minus 3I. Your J is 0. No need to write, guys. Don't need to write. It's 0 already. You sub inside here, you still get 0, right? So this will be 30 minus 3, 27. So this is 27I. Therefore, the magnitude is just 27. 27I simply means I'm going to the right by 27 unit. You don't go up, you don't go down. So the magnitude is still 27. No need to use Pythagoras. right? If you only go left or right, we can just find the magnitude. I want to ask you a question. If I go to the left by -8, what's the magnitude? The magnitude is just 8. Do you have to use Pythagoras? No need. Okay?
If this video helped you, give it a like. Let me know in the comment what topic you want next. You can get my additional mathematics books on Shopee or Lazada by searching Taliti, or check out my e-course and classes for full guidance. Don't forget to subscribe. I'll see you in the next video.